Hello everybody, Storm here. Welcome back to Kerbal Space program. In the last episode, we did several extended burns to, one, get the longbow escaped from Kerbal orbit, and then to get it on a MOHO intercept trajectory, and then to capture the low Kerbal Pass unmanned probe back at Kerbin, and then return its scientific payload back to the surface, which involved a bit of a staging mishap. I ended up, I don't know if it was my fault or there was some sort of glitch, but whatever happened, I was trying to activate the engines for the deorbit burn, ended up blowing the stack separator instead, which cut the fuel tank and engines away. And yeah. The kind of solution I came up with, like just a seat of my pants, was to grab the engine block, the main engine block, quickly and get it to basically re-rendezvous with the scientific payload, even though there was no docking port there anymore, to just make contact and then use the engines to push the payload into a lower orbit, then return the engine block back to a stable orbit, and I was able to get the scientific payload back to the surface without any further incident, which is good. Big pile of science, nearly 2,000 science, so that is great. I'm actually going to be holding off spending the science for a little bit. I want to wait till all of these scientific payloads return before I start spending things. Now, what I did in between episodes, I went ahead and advanced time to get the longbow to the MOHO intercept and ran the 28-minute capture burn to get the longbow actually captured into MOHO orbit. So that is the resultant orbit there. Worked out pretty well. I did actually modify it a little bit to be at a higher orbit because it wasn't going to be such a long burn. That doing that burn at a lower orbit was going to be a problem. I've run into that problem before. So, yeah, we are fine. Now we need to do the landing on MOHO, which is actually going to be a tad tricky. I've actually attempted this off screen a couple of times, and yeah, it's a bit tricky. It's a bit tricky because this engine, I might not design another lander with this type of setup before, or again. For several reasons. One, because it doesn't actually generate enough power to fully power that engine, that engine's thrust isn't consistent. So it makes doing the actual landing a bit tricky. I have failed on a few attempts, but I've been able to actually successfully do it at least once. So hopefully I will be able to do it today. Live. Alright, so let's go ahead and fuel the lander up. And let's transfer the crew. Transfer crew. There we go. Transfer crew. And we should be ready. Let's go ahead and undock. Alright, let's go ahead and back off. Extend the radiators and fire up the reactors. Both reactors should be good. There we are. Alright. Let's go ahead and flip us around retrograde. Oh, we don't need those on. And what I want to do... Let's see, are we far enough away? We should be far enough away. Okay, what I want to do is... Oh, that's right. I need to actually activate the engine. And I am not going to use the staging system this time, because I had that problem last time. I'm just going to manually activate that engine. And then... engage. I want to bring that down to about 60,000 meters, give or take. That'll do. Alright, now I'm going to use MechJeb to circularize at the periapsis. Create and execute. That should burn off a little speed. As we then plan for what the landing spot is going to be. I have an idea where we're going to want to land. Hopefully we'll be able to do it. I'll switch over to ground-based altitude. Oh, I probably want to retract that ladder, at least for the moment. Oh, got a whole bunch of stuff. Temperature scan, mystery goo, material study, a crew report, yep, atmosphere pressure scan, and an EVA report, which we'll do in a moment. Now, close this. Alright, there we are. So we'll go ahead and we'll get Dealy. EVA, grab that report. And then let's grab that data. Collect the data. Restore the experiment. Collect the data. Restore. Data. Data. Alright, store the experiments. There we go. Board the ship. We got ourselves another gravity scan. And an EVA report. Alright. I'll go ahead and grab those. As much as is possible. Because, I mean, it's science. Alright, now where I'm thinking I'm going to want to land is in this crater here. Because it's a nice flat area to land in. So I'm going to set up a maneuver node to burn off all of our horizontal orbital velocity. Because it's going to have to get burned off at some point. So we might as well burn it off now. And then pick a spot. Maybe right about there? Yeah, right about that. That's pretty nice and flat. 738.7 meters per second. That's a lot of meters per second. I'm going to actually go ahead and thrust limit this thing to about 48. So that it doesn't drain the batteries. It will take 4 minutes and 12 seconds. Okay, well, just a moment. And actually, I paused the recording because I had to go take care of some stuff right there. And I am actually continuing this at a later date. So there's a bit of a weird cut and jump there. Most likely. I'll have to see how it looks when we edit. But, alright, so we are at the point where I have the maneuver node set up and ready to go, and we're going to go ahead and execute it. This will be a 4-minute and 12-second burn. To bleed off all of this horizontal velocity. And I think I've mentioned before, it's been a couple of days, but this is going to be a bit of a tricky landing. So, I'll apologize if I repeat myself for some stuff I've already said. Alright, we have a gravity scan. You know what? I'll go ahead and grab that. Let's lower those landing legs. I want to have the landing data here in Flight Engineer, because there is a critical piece of information that we are going to need, and that is right here. Don't know if you're going to be able to read it because of the size of the font, and it depends on what resolution you're watching this at, but the suicide burn countdown. That is the number we are looking for. The suicide burn countdown is the amount of time we would have to wait until the point where we can slow down to 0 velocity at the landing point if we burn at maximum thrust, maximum available thrust, continuously. Which is actually the most efficient way of propulsively landing a vehicle. So, you know, with a suicide burn is you wait until the last possible moment to fire the engine. You fire the engine at full throttle and you hit the brakes as hard as you can with the hopes that when you get to the ground, you reach 0 velocity at just the point where you touch the ground. It is a tricky bit of business to achieve. Especially if you have a planet with an atmosphere that can cause all kinds of trouble for you. As SpaceX can attest to with their figuring out how to land their Falcon 9 boosters. Which I don't know about anybody else, but I have been paying very close attention to their Starship project, and I'm really looking forward to seeing that thing fly, especially once you get the super heavy booster on it. It's going to be nuts. If it works, of course. Alright, we've got a minute left on the maneuver, and if we look at the actual positioning of things, we are going to be significantly lower. Now, suicide burn countdown, we're seeing negative numbers there, which is not good. If the numbers are negative, it means you don't have enough time to slow down before you'll hit the ground. From the altitude that you're at with the amount of thrust that you have available. But remember, we are on a limited thrust setting here, so we have some wiggle room. And I'm actually going to keep this panel open for the engine stats because of the way I'm going to try and do this. Alright. 9 seconds. Alright, and as soon as that engine cuts, go. And then retrograde. Alright, and as soon as we're retrograde, engage the thrusters. We might have to burn off. Alright, suicide burn countdown is at a negative 1 minute and 8 seconds and climbing, which is not good. So I'm going to have to increase the available thrust till that number starts to come down. And actually, right about there, we're at 0.8 or 9 seconds. Let's see, if I put that at about 51%, or negative. Okay, 51.5. We're pretty good. EVA report. Yeah, that's not going to happen. Alright, now I'm actually going to go ahead and just do standard stability assist because as we slow down, that retrograde indicator can tend to bounce around. So alright. Suicide burn length 4 minutes and 3 seconds. Alright. Electric charge is dropping ever so slightly because we have the higher thrust setting. So we're consuming slightly more electric charge than what our reactors produce. So if this holds and it is correct, we should end up actually stopping and probably starting to go back up slightly before we reach the ground. 13. I can actually probably control with throttle controls at this point to control the suicide burn countdown. Make sure that we're good. Slow us down. Throttle down just a bit. Throttle back up. There we go. I gotta be ready to cut the throttle, like, quickly. So I don't want to burn any more fuel than I have to. One minute and 45 seconds till we reach the ground, according to the numbers anyway. We will see. There is a little bit of a target indicator showing us where we're going to land. We are actually starting to drift a tad. Alright, Burn off any horizontal velocity we have. Alright. We're going to need to... okay, we actually need to throttle down just a bit. Throttle down just a bit. Throttle back up. Bring that back. Okay, good. Good. Throttle it down, throttle it down. Back up, back up. Suicide burn delta V, 26 meters per second. Oh. Okay, yeah, that didn't quite calculate out right. It stopped us 500 meters above the ground. Okay, now we're going to have to kind of feather this ourselves. Alright. Slow it down, slow it down. I'm going to keep us around 5 meters per second. Give or take. Just a consistent downward velocity of around 4 to 5 meters per second. Get rid of that horizontal velocity. Get rid of that horizontal. We want to come nice and straight down. $200 meters to go. That's about, what, 50 seconds? Well, 140 meters to go. Yeah, we're wobbling all over the place. .8 meters per second. 3.7. 3.6. Throttle it up. Throttle it up. Slow us down. Slow us down. Bring me down about 1 meter per second. 1 to 2 meters per second. Hide the impact marker. And we're down. Excellent. Okay. I set my thrust limiter back to 100%. Alright, what do we want to do? We need a temperature scan. Yes, we need a seismic scan. Mystery goo observation. Extend that letter. Come on, extend the letter. Material study. Atmospheric pressure scan. EVA report. Take a surface sample and our EVA report. Alright, let's grab everything we need. Collect the data. Restore the part. Take the data. Log some gravity data. Take it. Okay, good. Take the data. Take the data. Take it. Alright, excellent. Store all of the experiments. Okay. And I should be able to do this and get an EVA report while flying. You can actually feel the radiation. Yep, because there's Kerbal, the sun there. All right, let's go ahead and get let's get Valentina out of there. Gonna get a real good suntan. Alright, so what we're going to do is we're going to plant the flag. Out of the frying pan. Or we say no, first Moho Landing is the name of the site. And the plaque text is out of the frying pan. ... There you go. Alright, now we need to get this thing back into orbit and get rendezvoused back with the longbow. And hopefully I have enough fuel left to do that. I should. Okay, now I think I mentioned this before, is that, let's see, if I warp like that, okay, yeah. Longbow is orbiting in this direction, so you need to take off and head south. So we need to head that direction. To get a polar orbit going like that. And yeah. Do a rendezvous. So let's go ahead and do it. Whoa, 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 whoa. I guess I'll grab a gravity scan. Alright, so what height do I want to get to for the orbit? I would say about, see, as long as the time the apoapsis is increasing, we're fine. 50 or 60,000 meters, I think, should be fine. Yep, we depleted the batteries, so we're running at reduced thrust. But our apoapsis, time to apoapsis is still increasing. So we are good. Yeah, I just want to get to the point where we can establish an orbit. Man, we're gonna be squeaking it close. We're gonna be really squeaking it close. Let's see if we can start adding a bit of horizontal velocity to this thing. Alright, 39, 40, 41, 42, 43, 44. 50,000. Cut the engines. Circularize at the next apoapsis. I believe we want to do. Create the node. Yes, 282.5 meters per second. I'm going to go ahead and tell it to do a thrust limited. Remove the nodes, create the node again, and execute the node. 282 meters per second. Oh, that is not going to give us a lot of wiggle room. There's 600. Give or take. So we're going to probably have a little over 300 meters per second to play with for the rendezvous. I really hope that's going to be enough. There's nobody aboard the longbow right now. But actually, the longbow should have remote control capability from Kerbal Space Center. I could, in theory, perform the rendezvous maneuver with the longbow. Not ideal, but it could be done. Okay. Alright, there we are. Let's see. Let's set it as target. And let's see what a transfer orbit looks like. (214 meters per second). That is not going to work. Relative speed is going to be 152.9 meters per second. That's really odd. Not that I don't trust this thing, but isn't there a way I could do this a little bit more efficiently? It's because that's an eccentric orbit. I can get within 23 kilometers. Oh, that's a better one. 237 meters per second. It's still 237 meters per second with a relative velocity of 123. So that provides a total delta V of about 360.6 meters per second, which is not enough. All right, then. We're going to have to do this the other way. We're going to have to do this the other way. Switch to... Gonna burn about 400 meters per second. I think so. All that stuff is already on board. All right. Change of plans. Set as target. Create the node for the bi-impulsive transfer. 131 meters per second gets us to... It's actually probably going to be more efficient at this particular point. Burn time 44 seconds. All right. Actually, let's clear it. Let's do another create node. Do we get anything cleaner than that? Not really. All right. Execute the node. We're flying by remote. The reactor is on, right? Yeah. Okay, I had hoped that I wouldn't have to drop to the lower orbit with this thing, but it is what it is. Okay, there we are. Now I'm going to tell them to match velocities with target at closest approach. 212 meters per second, 1 minute and 11 second burn, in 52 minutes. Execute that node. You know, I'm letting MechJeb do this because everything has to be very precise for this, because I can't afford to waste any delta V at all. And now what I may even do is actually do the docking with this. Because this thing's RCS thrusters run off of monopropellant. Alright, it is 6 kilometers away. Let's just see how close we get. See, the thing is, maneuvering this thing is going to be tricky. Not impossible, just tricky. Oh boy. No impact, no impact. No impact. Alright, good. Actually, I think I am going to switch to the other vehicle and do the docking that way. It shouldn't cost me too much lithium. It's just going to be so much easier from that side. Alright. Stabilize. Okay. Switch over. Alright, good. Target that. Let's control from the docking port. Give me my camera. There we go. Alright. Alright, let's flip us around so that we can see where we're going. Okay. Okay. Flip us around like that. Rolling everything doesn't matter. I just need to be able to do this intuitively. Okay. Alright, let's rotate us into the right orientation. Okay, there we are. Oh, no, no, no. There. There we go, there we go. Okay. Alright, we're lined up pretty well there. Okay, so. Just need to be patient. Once I have the vessel, the longbow, in the camera view, actually we need to move that way slightly. Alright, let's just accelerate slightly. Good. Alright, are we closing? Let's get closing speed to about 0.5 meters per second. There we go. Alright, we are lined up and on target. I don't care about roll at this point. I just want to get those docking clamps together. Bingo. And there we are. All right. Okay. So for the time being, what we're going to do is we're going to have these reactors shut down. This reactor shut down. This engine shut down. Separate all of that. There we go. Okay. And there we have it. Transfer crew. We'll move Valentina back into the command module, and then we'll move Dealey there back into the habitation module. Alright. And there we go. What I think I'll probably do is go ahead and actually end this episode here with that part of the mission all done. What I'll do is probably go ahead and fire up the escape burn off screen for the next episode, and then we'll start working on getting back to Kerbin. And we'll see if I have enough Delta V to actually make that work. That might be problematic. We shall see. We shall see. I have ideas if we don't have enough Delta B to make all the maneuvers to return to Kerbin work. I have ideas. But, you know, I'll have to see, play around with it, look at the numbers, and figure out what is going to work. And then we'll kind of go over that for next episode. So for now, I hope you guys enjoyed it. Thanks for watching. Go ahead, like, subscribe, and comment, and I will see you next time.